Senior Project, Transparent Gas Lift Valve, Louisiana State University.
Hello, my name is Quang Pham, and I'll be speaking to you today about our executive summary. Gas lift uses a technique in the petroleum industry known as artificial lift. This technique raises a fluid such as water or oil by pumping bubbles into an outlet tubing to increase the performance of production. This technique reduces the hydrostatic pressure in the outlet tubing and increases the pressure of the inlet tubing. The goal of our project today is to create a transparent gas lift valve model that can be used in the Petroleum Engineering Research and Technology Transfer Laboratory, also known as the PERC Lab at Louisiana State University. The main reason for creating a model like this is for educational purpose and instructional purposes. This design will be able to allow students to gain a better understanding of how artificial lifts operate and allowing them to visualize it at a real time during gas lift operations.
Hello, my name is Yamana Brown Government, and I'll be talking about project purpose and justification. The purpose of this project is to build a transparent gas lift valve, or TGLV as referred in this paper. This model to be used in an artificial lift experiment apparatus for demonstration at the PERC facility. Students of Petroleum Engineering program will be able to receive visual demonstration on how a gas lift valve operates, its role in the gas lift field operation, and the mechanics of the entire operation. The TGLV model will demonstrate the interaction between the injected gas and the fluids being produced. Currently, this laboratory experiment is being performed using a solid metal equipment. This makes it extremely difficult to gain an understanding of the interaction between the fluid and the injected gas. To be able to better comprehend the concept, a GTLV model will be designed and tested. This project will show the process and makeup on a lower scale, which will enable students to not only observe but to fully interact and gain a visual reference of the entire process. To be able to visually inspect the ongoing process of how gas lift valve operates and its contribution to artificial lift operations. This will help potential petroleum engineers grasp a better understanding of oil field operations. Not only will the device serve as an incredible learning device, but it will provide a reliable testing data, and it can be duplicated under controlled settings. Now I'm going to talk about the business objective of our project. The objective of the PERC Lab, located at Louisiana State University, is to continue building on the legacy of excellence in drilling and extraction, breakthrough research in producing quality future engineers. The transparent gas lift valve model will be able to help expand the instructional production, increase research efforts, and surface operation teachings. This project will be a great addition to the facility as a teaching tool that will help provide exceptional service to students.
Hi, my name is Leonte Barreto, and I will be talking a little bit about our project description. Gas lift valves are used worldwide in producing wells that cannot flow on their own. To solve this problem, gas is injected into the wells to increase the production rate of fluids flowing out of the reservoir. In the process, gas is forced into the annulus down to the wellbore through an injection pressure operated valve, also known as IPO, and then into the production tubing. As the gas enters the tubing string through the valve, it creates an aeration or a bubbling effect in the liquid column. The gas bubbles expand as they rise to the surface, displacing the liquid around it and reducing the density and weight of the fluid within the tubing. This decreases the flowing fluid pressure, creating a differential pressure between the reservoir and the wellbore and allowing the well to produce at its optimum rate. In this project, the process will be simulated by developing a smaller scale transparent gas lift valve, what we also call a TGLV, that will inject air into the water field production tubing. The valve will be built out of a high pressure transparent acrylic tubing in order to sustain pressurized air in a various hydrostatic water columns. Every mechanical part within the valve should be built out of a similar acrylic material, unless they are not rated to withhold the pressure necessary to open or close the valve. In such case, the acrylic material will be replaced by a stainless steel. The TGLV will then be tested and data will be collected for educational purposes. Some of our objectives and success criteria will have to be met to make this project successful. The model will have to be transparent in order to attain the purpose of the project, to make it easier for students to understand the artificial lift. It will also have to be functional in order to be able to demonstrate the students the mechanics of the gas lift valve and the movement of the fluids within it. The model should be presentable as well, in order to assist the audience visualize the process more easily.
Hello again, and now I'm going to be talking to you about the requirements that our group will face proceeding with this project. The transparent gas lift valve, or TGLV, must be diverse and operational. It has to be able to function as an actual gas lift valve and to perform its duties during a gas lift operation. The valve must demonstrate how energy from a charging chamber will build up and open the valve, releasing gas or fluid into the reservoir, creating an artificial lift to help with the production efforts in a downhole operation. It also has to be transparent. The whole purpose of this project is to create a device that is transparent, that will show the working mechanisms of how a gas lift valve will be operational. One more requirement is that it has to be able within constraints. Being able to build a device within a certain time frame that's given to us under a certain budget is going to be difficult, but be able to challenge us at the same time. The device has to be durable, and when I say that, I mean it has to be able to withstand certain pressures that we're going to test it under. The last thing that the TGLV must do is to have attainable results.
Today I'm going to be talking about the constraints of our project. One major constraint that lies as burden on the project is time, and the other one is money. Since there is going to be a budget for the project, an accurate plan will have to be made to avoid spending money on purchases that might be proven unnecessary in the future. Time is going to be a major constraint as well, because there is no extension for project deadlines. Now I'm going to be talking about the assumptions that we have to make for our project. First of all, since the model is going to be a small-scale gas lift valve, the fact that the model will operate in an identical manner as a full-size gas lift valve would have to be assumed to make the appropriate calculations. Also, water and airflow in the small-scale model will have to be assumed to be similar to the oil and gas flow in the full-size gas lift valve.
Now, I will be talking to you about what our project sponsors require us to deliver. Our sponsors require us to create a functional, transparent gas lift valve model that will be able to accurately demonstrate the mechanics in the valve to provide a visual and educational aid for the students. Thus, the TGLV model will have to be easily comprehensible upon display, as well as fully operational upon experimenting. The TGLV must also be presentable as a functional manner within the time frame agreed upon the project sponsor. Thank you for listening to our presentation. We believe that our TGLV will be a great addition to our PEAR Lab.